All right, so quickly, I'm going to go through the epithelial tissue notes. I went over this in class, but I want to have this here. Some of you, in case you need to kind of check this, or if you still have questions, or you want to refer back to it, that way you can kind of make sure you have what you need. Okay, epithelial tissue, all right, is going to be things that cover or line surfaces of the body. So we're talking about things like your skin or parts of your digestive tract, or all kinds of examples. So when we talk about the different epithelial tissues, we're talking about these coverings or linings. Remember, tissues are made of cells, right? We learned about that in Unit 1. Cells make up tissues. So when we talk about these tissues, right, like epithelial tissue, we're going to be talking about specifics of the cells. When we look at epithelial tissue, the way we're going to classify these, we have two ways. The first is the number of layers. We have either simple, which is a single layer, or we have stratified, which is multiple layers. So we have a single simple layer here, or multiple stratified here. Okay. The other one is cell shape. Cell shape is squamous, which are these flattened. I think of them the way I remember it is they're kind of like squashed down. Cuboidal, which are cubes, and columnar, which are columns. Okay. When we combine these names when we combine these classifications, that's how we come up with the names for a lot of different types of epithelial tissue. So, for example, we have, multiple layers would be stratified. If it's multiple layers of squamous, it's stratified squamous. If it's one layer of a squamous, it's simple squamous, right? So you combine the number of layers, simple or stratified, with the shape, and that gives you the names for many of the different types of epithelial tissue. However, it doesn't give you the names for all of them because there are a couple exceptions, and we'll get to those in a second. Notice how the picture here, right, the illustration looks a little different from the actual microscope image. So when we talk about the microscope image, remember we're going to be talking about the different things that you actually see, and that can be a little more difficult or a little harder to interpret than the illustration sometimes. If you're given these in class, you'll be given, well, not necessarily during the lab, but if you're given some on on a quiz or something like that, it'll be pretty clear in the microscope image, the number of layers and the shape. I'm not going to try and trick you there. Okay, back to the two exceptions. We have pseudostratified, right, and transitional. Both of these kind of provide like a protective function. Pseudostratified, right, in the name, pseudostratified means like false stratification. So like it has this idea that it looks like multiple layers. So you can see in the picture, it looks like multiple layers, but it's really only one. Okay, and transitional, the thing about transitional is that it can stretch. Okay, so transitional will be found in areas of the body, certain systems where you might have stretching occur, like the urinary system, specific parts of the urinary system, things like that, where you can have stretching. Obviously, it's limited, but you have a little bit of stretching and then it can return without damage to the tissue. So the big idea with epithelial tissue is that there are a lot of surfaces in the body, right? We mentioned those. You have skin, you have surfaces, in the tubules in your kidneys, you have in your lungs, in your esophagus, digestive tract, all these surfaces in your body, right? And clearly the functions of all those surfaces are not identical, right? The function of your skin is going to be different than the function, of certain parts of your kidney or in your digestive tract. So when the functions are different, we can figure out and we can see and we can, classify these things into different categories. We know that the structures are different. Structure and function are related. Okay. The structures that make up systems or tissues or whatever are going to relate to the function of those systems or tissues or whatever we're talking about. Right? Structure relates to function. This isn't unique to anatomy. It's not unique to biology, although it's incredibly important for both of those, right? But we see it in engineering. You see it all over the place. Structure is going to relate to the function. What something is composed of, what it's made of, how it's put together is directly related to what it does and how it works, okay? And that's no different here with the epithelial tissue. In general, we have functions like protection, like your skin, absorption in your lungs, filtration, like your kidneys, secretion, parts of the digestive system or, in the certain parts of the respiratory tract, things like that. We have different functions. But when we look at these functions, okay, the functions are pretty different. Protection is very different from absorption, right? So what your skin does and how parts of your lungs are working are very, very different. So it makes sense that the structures are different. So as a general rule, it's not necessarily the case every single time, but as a general rule, if it's protection, it's going to be stratified layers or columnar cells, because stratified means multiple layers and columnar are thicker of the three types that we talked about. So it would make sense that you have thicker either layers or thicker cells in general if you're trying to provide protection. And then if you're trying to have absorption, filtration, or secretion, having a simple layer, a single thin layer, or squamous or cuboidal cells, that would also make sense, right? So if absorption, filtration, and secretion, you don't want thick layers that things are going to get caught up in, right, and kind of clog the system. That wouldn't be good, all right? But when we have a simple layer, a single layer, so you can have simple squamous, which is a single layer of like that squashed thin cell, right? That's going to be a pretty thin layer and would be good for things like absorption, filtration, or secretion. So that pretty much sums up this quick overview of epithelial tissue. Obviously, we didn't touch on every single specific point, but if you have questions, please let me know. Thank you.